If we don't have any questions, we are going to move into chapter 2. You might have wondered, well, why did we even bother to look at limits? Did we wonder?
A little bit, yeah.
A little bit? Okay. What did you wonder about? Like limits, in what way?
Well, keep in mind that was a week ago and I had a busy week, but from what I remember, the main thing that I was talking about in my head is this doesn't seem, because everybody tends to talk about calculus being very, very complicated in the rest of it, this seems pretty simplistic in the rest of it, so this is probably foundation work, but for what?
But for what?
Yeah.
Okay. Anyone else?
No, that's about it.
Huh?
No, that's about it.
That's about it? Okay. Well, we did limits to get into the concept of derivatives. As I mentioned, unless you plan on becoming, a math major or a statistics major or get into engineering, you wouldn't need limits. Even if you get into engineering, limits is very theoretical, or limits are very theoretical. So the purpose as to why we did limits is to explain the concept of derivatives. With me? Okay. What do we know about slope of a line? Do you all know y equals mx plus b?
Yep.
Okay, hopefully. Now, what can you say about y equals mx plus b?
It determines the rate at which, how quickly a line either goes up or falls down.
Okay, it tells you how quickly a line is going up or it's going down. Does the entire equation tell you that, or a bit of that equation tell you that? Go on. I forgot your name, so we'll have to do this again.
Brian.
Oh, Brian, okay.
I'm sorry. Brian. So the B is going to be your y-intercept.
Okay.
And the MX typically is your rise over run.
The entire mx part?
No, just the X.
Just the x part?
Now I'm confused.
Okay.
Maybe.
Anyone else? Now he was right. B is the y-intercept. Leo over there told us, oh, it is going to give us how a line increases or decreases. Well, the entire equation of the line, which is right there, doesn't tell us that. But a part of it does. So Brian went, oh, it's going to be x.
It's just the M.
It's just the m. And m as a name.
Just
The slope. And we all know slope is simply rise over run. Yes? We know how to find that. Okay, if someone asked you, well, could you please explain what slope is? What would you say?
Y over X. Who are we explaining this to? Just like a normal person or somebody who knows math?
Well, a person who doesn't know math.
Okay.
I mean, if you went and told them, oh, it is rise over run, like, what are you talking about, right? If you have to put it in simple terms so that they understand.
It's all the possible answers of an equation on a graph.
Possible answers of the equation on a graph, okay. Colton? No. Dylan? You changed your name in like 1 week. I think Leo kind of gave me the answer already. So the slope tells us the rate of change. That is of course, there is the part of being a constant, but I don't want to complicate things. So for the time being, we'll simply say that slope is simply the rate at which the line increases or decreases. Now, if y is 2x plus 1, do we have an increasing slope or an increasing line or a decreasing line?
Increasing.
Increasing. M is 2, which is greater than 0. M is positive, so it has to be increasing. Is that line increasing or decreasing?
Decreasing.
Huh?
Decreasing.
Decreasing. Obviously, we know that is an increasing line. M is positive. My question to you is, of the two lines, which is going to increase at a rapid rate? The one, no, we're simply looking at A and C.
C,
Why?
because it has a greater x value.
Greater X value.
Like it has a stronger slope.
It,
Because it has 8x and then
right,
2x.
so it has a stronger slope, not the X value, the M value. So M is larger in the last equation, so naturally it is going to have a rapid rate. Good? Okay, going to sketch those two lines, but I guess we could use the calculator, right, to do that. This way you know how to use the calculator also, these don't work. Yeah? You always wondered why they have those switches, when these are the only things that doesn't work. Oh, it's banana. Can we see? Okay, I'll put the thing down. So if you don't have the calculator, and if you simply want to, learn the calculator for the exam, you can always go to the site myapps.fgcu.edu, and you have to select student and put in your username. Make sure you select FGCU student. And if you scroll down, hopefully it's still there. Should be. You have the calculator. So it doesn't matter what computer you have, may it be PC, Mac, it will simply work. Good? For some reason I keep getting that error. but you can only use that on campus computers, and if you want to use it at home, you have to know how to use VPN. So you have to VPN, log into FGCU's site, and then use this. Okay. So I want to graph these two lines. So to graph in your calculator, how many of you know how to use this calculator? Okay. So this is for people who do not know how. So select y equals and type in the equation 2x plus 1, that is the first one. Yes. And graph. Oh my. They are going to remove this. Unbelievable. Right. I can complain to IT again, but they just ignore me because I whine too much to them. So that is the first line. The second line is 8x plus 1. So the first line was that, the second is that one, correct? So obviously, this particular line has a smaller rate of change compared to that line. Do we agree? Okay. I'll try to use the calculator more as we go along if it lets me. If not, I have an alternative. Has been terminated and will be removed. Great. Let's take the first one. So the purpose of this slope is to give us information about rate of change. Good. So that's 1. 2, it's about 5. Okay, here is a question. Suppose I pick an arbitrary point. Let's say 1. What is the rate at 1? At what rate is the function increasing at 1?
The slope from 1?
No, just for the line, we know the slope is 2, right? This is y equals 2x plus 1. My question is, exactly at 1, what is the rate of change at? Still 2, right? Now I want to move to 0, and I want to know the rate at x is equal to 0. What is the rate?
1.
Why 1? What is your name?
Bracken.
Bracken?
Bracken is German.
Oh, neat. It's unique.
Yeah.
It's the first time I've heard that name. Probably in my entire life. Bracken. It's like Kraken.
Yeah.
Bracken's Kraken. Okay, moving on. 0, Bracken said it is 1, but 1 is the value of the function, right? I'd like to know the rate at which the line is increasing at x is equal to 1.
0.
Why 0? If it is 0, then the line's not increasing, it's flat, right?
The line doesn't cross past, or it doesn't cross through 0.
Okay, any other answers?
Is it still 2?
Is it?
Yeah, because it's the line still going.
Right, what is your name?
Sorry?
Name?
Connor.
Huh?
Connor.
Connor. So Connor says it is still 2. He is correct. It's increasing the same rate. What about, I pick an arbitrary point, say this is at 3. I'd like to know the rate at x is equal to 3. What is it? Still 2, right? So no matter where I look at this function, the rate is still the same because the line is increasing and it is increasing at the same rate. With me? So slope here gives the rate of change and that slope is constant. So it is easy when we look at a line. It's an arbitrary function. I know it's a cubic polynomial, but if I picked a random x value, 1, another x value right there, 2, 3, 4. Good. I would like to know where the behavior of the function at x is equal to 2. We'll start at 2, then we can go to the other things, other values. At x is equal to 2, is the function increasing or decreasing? It's decreasing. Why is that? Connor?
It's going down from x equals 2.
So if you look, you don't have to look exactly at 2, but in the neighborhood of 2, the line is going down. Yes? So it's decreasing. What do we know about a line that is decreasing? Its slope is negative. So at x is equal to 2, the function is decreasing. And the slope is negative. What about at x is equal to 4? It's increasing. If you look at or about x is equal to 4, the line is, or the function is going up. So the slope has to be positive. Here comes the tricky part. What is happening at x is equal to 1?
It's remaining.
Huh?
Yeah, that is. Sorry. I think it's remaining constant at that point, but it's starting to decrease at that point. Wow.
So if you look exactly at x is equal to 1, it's constant, right? So if a line has a constant slope, if you draw a line over there, it is going to be a flat line. Do you agree? What is the slope of a flat line? Flat line? 0. It's not function is constant, since they say it's not increasing or decreasing. I'll just call the rate or slope is 0. what do we think is happening right there? X is equal to 3. The slope is still 0, right? It's a constant. If you look at a line, no matter where you look in the domain of the function, the slope is the same. Yes? But if you look at a different function, the slope is not the same in the domain of the function. In some places it is positive, some places it is, in some places it is 0, some places positive, other places negative. Correct? So can I say that the rate is changing with respect to the value of x? Yes. In this case, the rate is not changing with respect to the value of x, it is constant. Here, the function is changing with respect to the value of x, so it is no longer a constant, rather it is a function of x, because it is changing with respect to x. Do you agree? Okay. Going along with rates of change, there is something called average rate of change. So average rate of change is the rate of change on an interval. I will do the easy one, which is A, and I'll let you try B and C. I'll give you a hint, C doesn't require any mathematics, it just requires a bit of thinking, and that's it, you could get the answer. Let's erase this side. If you have your calculator, go ahead and graph this. Just for practice, I don't need a calculator, so. What should it look like? If you graph this? What should the graph look like?
So it's straight line.
It's a straight line. Great. What is the formula for slope? We all know it is rise over run, correct? But there is a formula in algebra. Do we remember?
Y minus y1 over x minus x1.
So close.
I got the one.
It's
mixed up.
y2 minus y1 minus x2 minus x1.
Y2 minus Y1 divided by X2 minus X1, because those two are individual values. So have we seen this before, that euro sign means in, so X is in this interval 1 to 2. So at 1, the value of y, you just plug it in the equation, you get 3. Yes? So this point is 3 on the y-axis, so 1, 3. When x is 2, you just plug in the value of x. 2 times 2 is 4, 4 plus 1 is 5. Correct? Now, how do we go about finding the slope? You just use the formula, right? Rise. Run. I asked you to rise and no one rose. I'm asking you to run and no one runs. Did you get it? Rise over run. So, what is y2 at that point? Five. Y1 over here?
3.
3. So we get 2. What is x2? x2 is 2. x1 is 1.
So that's 1.
1. So the answer is 2 over 1, which is 2. Correct? That 2 matches that 2. Do you agree? Okay. I want you to find the average rate of change on the interval 4 to 6. I'll give you about a minute. So x1 would be 4, x2 is 6. Connor?
Don't, as long as we have the silver line, isn't every spot really 2 or?
Yes.
As long as
That is the point I'm trying to illustrate. So some might recognize it right away, some it takes time. We have the x values, which would be 4 and 6. We just have to find the y values. What is y1?
13. No, 9, my bad.
9,
9.
right? 2 times x value plus 1. y2 is 2 times the x value, 6.
13.
So we have y2, y1, so the slope would simply be y2 minus y1 divided by x2 minus x1. 13 minus 9 divided by 6 minus 2. Oops, 4. 13 minus 9 is 4. 6 minus 4 is 2. You get 2. Good. What is that 2 match? That 2 is the same as that 2. Correct. Who can tell me what the value of or answer to C is?
2 is it?
2. Why is that, Liam?
Well, it's asking for the instantaneous rate of change, so it's asking for the rate of change between just two x values, which...
But there aren't 2 x values. There's just 1. X is equal to 3.
It's still going to be 2 because the rate before it was equal to 2, and it's continuing to go at 2 because the line is constant.
If you go back to, say, 20 minutes ago, I was drawing that line and I said no matter what point I pick on that line, the rate will be the same, right, at any given point. So at x is equal to 3, the rate would still be 2. Because that is the slope, right? Can I erase this? What can we deduce from whatever we did? So for a line, average rate of change is simply a rock. It's rock, not Iraq. AROC, average rate of change, IROC, instantaneous rate of change. Instead of writing it out each and every time, you can simply abbreviate it and write it that way. So they are the same, and it will equal to the value of the slope. Can I erase this side? simply write it as AROC, which stands for average rate of change. Shown you how to graph. It's not going to work. X cubed minus x plus 1, can you see? Okay. That's what it looks like. We would like to find the average rate of change between these two values of x, 1 and 3. Agreed? So we need to find the value of y first, because the slope would be the average rate of change. We know the value of x2, we know the value of x1, we just have to find the value of y2 and y1. What is the value of y2?
4 and 3.
How much?
4 and 3.
4 and 3.
Yeah.
How'd you get 4? 3 cubed is 27.
Oh my god.
27 minus 3 is 24. 24 plus 1 is 25. What about the value at 1?
1 over 1 comma 1.
Simply plug in the value in there. You get 1 minus 1 plus 1. So y2 is 25, y1 is 1, x2 is 3, and x1 is 1. 25 minus 1 is 24 over 2, which is 12. Agree?
Yeah.
12 is a positive number. So I'm going to conclude that the function is increasing on the interval 1 to 3. Do you agree?
Yeah.
Is the function increasing between 1 and 3? Yes. Now can someone tell me, or give me the answer for part C? It wants to know, is the IROC at x is equal to 3 same as the average rate of change for x in 1 to 3? In other words, the question is, the rate at x is equal to 3, is it the same as 12? Look at the picture carefully. Yes? Okay. How many of you say yes? How many say no? Why not? Brian?
Because the graph is changing exponentially.
The graph is changing in a sort of exponential way, right? From 0 to 1, the increase in the value of y was about 1, correct? But from 1 to 3, all of a sudden it's jumped to 25. So beyond this point, it is going to raise in an exponential way. In the previous case, for a line, it was constant at every single point. That is not the case here. So do you believe that the slope here would be the same as the slope there? It's constant here, positive there. Do you believe that the slope here would be the same as the slope there? Constant here, negative there. Do you believe that the slope at any point over here will be the same as there? No, increasing, decreasing. So the point we're trying to make is, if you have a function other than a linear function, which is a line, the instantaneous rate of change and the average rate of change will not be the same. But in practice, we would like to know the instantaneous rate of change. We would always want to know at a given instant, how is something changing? So how would we go about finding the instantaneous rate of change for a function that is not linear? That's where the derivative comes into play. Good? Yes? So next time I'm going to start with difference coefficients and move on to derivatives. Watch out for that video next time. If you have questions, talk to me. If not, I will see you on Wednesday.